The volume of a sphere is increasing at a constant rate of 2,525 cubic inches per minute. In the year 2525, it's an old song. If man can survive, I don't remember the words, it's irrelevant. At the instant when the volume of the sphere is 3,200 cubic inches, what is the total rate of change of the surface area of the sphere? Oh my goodness, I don't know. Let's start writing stuff down. Let's use black this time. The volume of a sphere is increasing at a constant rate. Ooh, they gave us the rate of change of the volume, and it was 25. If man is still alive. You may want to Google the lyrics, I guess. At the instant when the volume of the sphere, they gave us the volume of the sphere. It's 3,200 cubic inches. What is the rate of change of the surface area of the sphere? This is similar to the last problem, just different formula. So I'm going to go a little bit faster. And we are dealing with the sphere, okay? So let's jump all the way to the end. The formula for the area, surface area of a sphere is 4 pi r squared. We'll take the derivative of that and we'll have dA dt equals 8 pi r dr dt. There we go. And we'll just start figuring out what we know and what we don't know. dA dt is equal to 8 times pi times the radius. Oh man, I don't know that. Times dr dt. Oh man, I don't know that. Okay, we're stuck, right? We were going to go ahead and jump to the final answer, but there's a lot we don't know, but there's a lot we do know to help us get there. We're dealing with the surface area of a sphere, but sometimes we have to back up and deal, in this case, with the volume of a sphere. Switching colors. The volume of a sphere is 4/3 pi r cubed. And we will keep going with that. So 3,200 equals 4/3 pi r cubed. Let's solve this thing for r. I'm going to jump straight to r, actually, and we're going to do a lot of this in our calculator. So be careful. All right, 3,200 would be multiplied by 3, divided by 4, divided by pi, and then cube rooted. I'm going to just raise it to the 1/3 power. That's the same thing as cube rooting. You can go to the math menu and retrieve the cube root if you like. There we go. The radius, which I will now store as r, stow r, is 9.142. 9.142 inches, if you want to get technical. All right, fantastic. 9.142, also known as r. I still don't know dr dt. Man, got to do a little more calculus. Never should complain about that. Volume is 4/3 pi r cubed. I already wrote that once, let's write it again. The rate of change of the volume is 4 pi r squared dr dt. There we go. We're going to plug some numbers in. Let's keep going. So 25. It was a very obscure song. Times the radius. I'm just going to call it r squared because I'm running out of room. And then dr dt. And it looks like I'm really not doing that much. But I do know what r is now, right? So let's solve. Dr dt is going to equal something. And that something is 25 divided by 4 divided by pi divided by r squared. R squared. And I got 2.404. And if you want to get technical about it, it is inches per minute. All right, so 2.404. Let's fill this out. Let's figure this out. And actually, instead of using this number and this number, we need to use the numbers in the computer calculator. I'm going to store this one as D because it's dr dt. There we go. Call it whatever you want. All right, I'm back over here now. 8 times pi times r times d. And pick the right color. 552.422. Okay, what? Area, square inches. Time, minutes.